Hello everyone. Today, we are going to learn about solving linear inequalities in one variable. By the end of this lesson, you will be able to solve inequalities and represent the solutions on a number line. Here are our learning objectives. Define and identify linear inequalities in one variable. Apply the rules for solving linear inequalities. Represent solutions on a number line. Let's start with a quick review. First, remember that an equation shows that two expressions are equal, connected by the symbol equals. For example, 2x plus 5 equals 9. By using additive inverse property, we will subtract negative 5 from both sides. We will get 2x equals 4. Dividing both sides by 2, we will get an answer of x equals 2. But what if the two sides are not equal? That's when we use inequalities. What is an inequality? An inequality compares two expressions using symbols like greater than, less than, greater than or equal to, or less than or equal to. Here's a quick table. Try to observe it. For the meaning of the first symbol, that is greater than. For words x is greater than 5. Second symbol, less than. Words, x is less than 5. Third symbol, greater than or equal to. Words, x is at least 5. Fourth symbol, less than or equal to. Words, x is at most 5. A linear inequality in one variable looks like ax plus b less than 0, ax plus b greater than 0, ax plus b is less than or equal to 0, ax plus b is greater than or equal to 0. Where a and b are real numbers and does not equal 0, here's how we solve linear inequalities. 1. Simplify both sides. Remove parentheses and combine like terms. 2. Isolate the variable. Perform operations like addition, subtraction, multiplication, or division. 3. Warning important. If you multiply or divide by a negative number, you must reverse the inequality sign. 4. Write the solution set in inequality or interval notation. 5. Graph the solution on a number line. Our problem is solve x plus 3 less than 8. Remember, solving an inequality works almost exactly like solving an equation. Our goal is to isolate x on one side of the inequality symbol. We start with step 1. Subtract 3 from both sides. We take x plus 3 less than 8. We subtract 3. X plus 3 less than 8 to 3. The 3's cancel out on the left, and 8 minus 3 gives us 5 on the right. This leaves us with our solution in inequality form. X less than 5. Step 2. Write the solution set in inequality or interval notation. The solution x less than 5 means that any real number less than 5 will make the original statement true. On the number line below, we use an unfilled circle at 5. Why? Because the less than symbol is a strict inequality, meaning 5 itself is not included. The shading goes to the left, towards the smaller numbers, stretching all the way to negative infinity. Finally, we write this solution using interval notation. Negative infinity, 5. The parenthesis next to the 5 shows that 5 is excluded. The parenthesis next to negative infinity is always used because you can never actually reach infinity. And there you have it. The solution to x plus 3 less than 8 is x less than 5, or infinity, 5. Example number 2. Just like before, we want to isolate the term with the variable, negative 2x. Step 1. Subtract 6 from both sides. We take negative 2x plus 6 is greater than or equal to 10. We subtract 6. Negative 2x plus 6 to 6 is greater than or equal to 10 to 6. The 6's cancel on the left, and 10 minus 6 is 4. This leaves us with the simplified inequality. Negative 2x is greater than or equal to 4. Now, we move to step 2. Divide both sides by negative 2. We write negative 2x over negative 2 is greater than or equal to 4 over negative 2. Step 3. If you multiply or divide by a negative number, you must reverse the inequality sign. When we divided negative 2x by negative 2, we got x. When we divided 4 by negative 2, we got negative 2. Because we divided by a negative, the greater than or equal to sign flips to less than or equal to. This gives us our final solution in inequality form. X is less than or equal to negative 2. Now for step 4. Write the solution set in inequality or interval notation. The solution x is less than or equal to -2 means all numbers that are -2 or smaller. Let's look at the number line. Notice the circle at -2 is filled in, a closed dot. This is because of the or equal to part of the less than or equal to sign. The number -2 is included in the solution set. The line is shaded to the left, going towards the smaller numbers, stretching indefinitely to -infinity. In interval notation, we write this as -infinity, -2. The parenthesis is always used next to -infinity. The square bracket is used next to -2 because -2 is included in the set. So, the complete solution to -2x plus 6 is greater than equal to 10 as x is less than or equal to -2 or the interval is -infinity, -2. Mastering that sign flip is the key to success with these problems. Let's tackle example number 3 and solidify that crucial rule about negative numbers. Our problem is solve -3x plus 4 less than or equal to 10. First, we follow the same process. We want to get the -3x term by itself. Step 1. Subtract 4 from both sides. We start with -3x plus 4 less than or equal to 10. We subtract 4. -3x plus 4 to 4 less than or equal to 10 minus 4. The 4's cancel on the left. On the right, 10 minus 4 is 6. This simplifies the inequality to -3x less than or equal to 6. Now for the final move. We need to divide to get x alone. Step 2. Divide both sides by -3. We set up the division. -3x over -3 and 6 over -3. Notice what we are dividing by, a negative number, specifically -3. This means that the less than or equal to sign must be flipped to a greater than or equal to sign to keep the inequality true. Let's finalize the solution for -3x less than or equal to 6. Step 3. If you multiply or divide by a negative numbers, you must reverse the inequality sign. We were dividing both sides by -3. -3x over -3 becomes x. 6 over -3 becomes -2. The less than or equal to sign flips to greater than or equal to. Our final solution in inequality form is x greater than or equal to -2. Step 4. Write the solution set in inequality or interval notation. The solution x is greater than or equal to -2 means we are looking for all numbers that are greater than or equal to -2. Let's look at the number line. The circle at -2 is filled in, a closed dot. This is because of the or equal to part of the greater than or equal to sign where -2 is included in the set. The line is shaded to the right, going toward the larger numbers, stretching indefinitely to +infinity. In interval notation, we write the solution as -2, +infinity. The square bracket next to -2 confirms that -2 is included. The parenthesis is used the next to +infinity, since we can never include infinity. Perfect. We've successfully navigated the sign flip rule to solve 3 different examples. Remember, when you multiply or divide by a negative, flip the sign. To wrap up our lesson on solving and graphing inequalities, let's review a handy summary table for when graphing. This is the key to correctly representing your solutions on a number line. First, look at the rows with the open circle. An open circle means the endpoint is not included in the solution set. When you see the less than symbol, you use an open circle and shade left towards -infinity. When you see the greater than symbol, you use an open circle and shade right towards +infinity. Next, look at the rows with the closed circle. A closed circle or a filled dot means the endpoint is included in the solution set, which is why you see the or equal to line under the symbol. For less than or equal to, you use a closed circle and shade left. For greater than or equal to, you use a closed circle and shade righty. Remember this table. No, equal to, line means open circle. The equal to line means closed circle. Less than means left. Greater than means right. Keep this chart in mind, and you'll correctly graph your inequality solutions every time. That concludes our lesson on solving linear inequalities. Great work, everyone. Now that we've covered all the key rules, including how to flip the sign when dividing by a negative, it's time to put that knowledge to the test. Let's practice solving and graphing linear inequalities. On the board, you see 3 problems. I want you to solve each one. Write the answer in inequality notation, like x less than 5, and also sketch the graph on a number line, paying close attention to whether you need an open or closed circle, and which direction to shade. Here are the problems. 1. 2x minus 5 greater than 7. 2. 5 plus 2x is greater than or equal to 11. 3. 12 minus x is less than 9. Take a few minutes now to work through these problems. Pause the video or take out your scratch paper. That brings us to the end of our lesson on linear inequalities. Before we finish, let's quickly review the 3 most important points to remember. First, remember the fundamental difference between an equation and an inequality. A linear inequality shows a range of solutions, not just one value. This range includes every single real number that satisfies the condition, which is why we need notation like x is less than 5 or the interval, -∞, 5. Second, this is the rule you must never forget. Solve it like an equation, but reverse the sign when multiplying or dividing by a negative. This is the number 1 source of error in solving inequalities, so always double-check your last step if you divide by a negative number. And finally, always make sure you completely represent your solution. Represent your solution algebraically and graphically. The algebraic part can be the inequality notation or the interval notation, and the graph must correctly use open or closed circles and shade in the correct direction. Left for less than, and right for greater than. That's all for our lesson on solving and graphing linear inequalities. You've worked through some tough problems and learned some crucial rules. Give yourselves a pat on the back. Thank you for your attention and hard work. Keep practicing, and you'll master this in no time. Have a great day.